And here's the question that's going to connect to what we saw in the getting started at the beginning of solving quadratic inequalities. Because we're going to have a quadratic inside of a square root happen in this equation. Because f of x is the square root of x. Again, I'm just going to visualize what that graph looks like. There's our square root graph. And g of x is a parabola shifted down 4 units. So I have a picture of what that graph looks like. We want to determine an explicit equation and then state its domain. So same question as we did in question 2. We're just dealing with square roots and parabolas now. And the domain part is what's going to be interesting in this question. So in A, g of f of x, well, f of x is the square root of x. And then, what happens in g of x? It says, whatever you plug into g of x, it gets squared, and then you minus 4. So I'm going to take the square root of x and square it. And then minus 4. What is the square root of x squared? Just x. And so we get an explicit equation that says x minus 4. What kind of graph is that? That's a straight line. And now you're going to be tempted, because it said state the domain, you're going to be tempted to fail. You're going to be tempted. What's domain of a line? You're going to be tempted to do this. Can you see yourself saying, that's the domain of a line? And then we get it wrong. Why is it wrong? Well, we have to check throughout the function to make sure we have no non-permissible values anywhere. What happens if I plug in a negative 5? It's okay here. It's bad here. It's bad here. Negative 5 is not allowed, because you're not allowed to take the square root of a negative. Even though your square root went away in the end, at the beginning, right? If you think of it this way, what does g of f of x mean? If you go back to your father's shop, he's got the two functions. He's got, I should do this one. The f of x function, which is the green one, would be first, and then the g of x function would be second. And this one is the square root of x, and this one is x squared minus 4. And in that jar of never, ever, ever numbers would be all the negative numbers. Because as soon as you throw a negative number into this first function, boom, it explodes. What would be a good exploding one today? Oh, this is fire. Oh, that would be bad. Any negative number in there would make that first function explode. So our domain for this first one is not everything. It is just bigger than or equal to 0. Part B, f of g of x, well, g of x first is x squared minus 4. And then f of x says whatever you put into f of x, you just take the square root of it. So if we put an x squared minus 4 into f, all we're going to do is square root it. And this is where that idea that we looked at right at the beginning comes in. To find our domain, we need to know when x squared minus 4 is bigger than or equal to 0. We have no restrictions in the first line. X could be anything. But we know that we can't take the square root of a negative number. So that inside of our square root, that x squared minus 4 has to be bigger than or equal to 0. So how do we solve this? Well, we make it equal to 0. So that means x squared is equal to 4 and x is equal to plus or minus 2. We can draw our number line with minus 2 and 2. It can equal 0, so those could be filled in. And you could find out where is it true, where is it false. You can find out where it's true or false in two different ways. The most common way is plugging in test values. Test something between negative 2 and 2. Try 0. 0 minus 4 is negative 4. Is negative 4 greater than or equal to 0? False. You could test a value bigger than 2. Try 3. Plug in 3. 9 minus 4. That's bigger than 0. And same thing over here. That's bigger than 0. That's one method, is to just do test values and check. The other method is to imagine this as the actual graph of x squared minus 4. Can you see that that would be a parabola with those two x-intercepts? Can you see that the sections that are where the y values are bigger than 0 are those two sections? And that matches up with this true and this true. Because we're looking for where it's positive, because we can only take the square root of a positive number. So therefore, when writing the domain here, we can say in interval notation, it's from negative infinity to negative 2, square bracket 2 to infinity. Or in set notation, x is less than or equal to negative 2, or x is bigger than or equal to 2. Okay, so question 6 has some examples from example 2 and example 3 and question 10.